Hello, everyone. In this week's session, uh, which will be week 8 now of the tutorials, we're going to have a look at a certain set of tools within Creo that allow you to create. Go on, is somebody just chipping in there? No? I'll keep going. So, yeah, we're in this portion of the learning materials. And the tools that we're going to look at essentially allow you to take a product design. So this would have relevance to the knife design that you've been set as a task for the assignment. And if part of that design was going to be injection molded, these tools would allow you to create the molding tool from the actual part design itself. So again, to relate it back to the task that you've been assigned for the project work, the assignment, you are tasked with producing a design for a craft knife that has an injection molded, or it has several injection molded components. And so in order to produce those components, you would need to create some kind of molding tool. Inevitably, that will end up being made out of some form of metal. And these tools that we're going to look at within Creo, these add-ons to Creo, allow you to create that molding tool. And it allows you to bring your original part design in and sort of design the molding tool around that part design. So the PDF that we're going to initially work from is this PDF at the top of the list here. So if you want to get that open in a separate tab, and then the files that we're going to be using are contained within that exercise files.zip. So you're going to need to download that. And the tools that we're going to be using here, I don't think they're in the student version of Creo. So again, just like last week, when we were using the simulation tools and we needed to log in through the virtual desktop, I think we're going to have to do the same thing this week, because the student version doesn't have this molding tool add-on that we're going to actually do some work in this week. So if you want to get logged into the virtual desktop, if you're not already logged in, you can be doing that in the background, and I'll just talk us through the kind of intro to this PDF, and hopefully everyone will be able to get logged in while I'm doing that. So this is the PDF that we're going to do our sort of initial exercise from. And what you're looking at on the screen there is a screen grab of the finished molding assembly, essentially. So I've put these little orange lines just marking which part in the feature tree or in the model tree relates to which graphical sort of block that we're looking at on the right hand side there. So essentially, there's a workflow that you have to work through when you're creating these molding tools. So when you're using this functionality within Creo, you tend to work through these basic steps that are listed below. So the first one is you create a new mold manufacturing assembly. So this screenshot, hopefully you should be able to tell that it's an assembly of parts. In this instance, these parts have special properties, but it is just an assembly, very much like any other assembly that we would come across in Creo. So that's your first step. You tell Creo that you want to create a new file. You tell it that this new file is going to be manufacturing assembly. And then there's a subclass within manufacturing assemblies. that is molding assemblies. So you want to create a new mold from a part design that you have already created. The second step is you import your part model. So in this example that we're going to have a look at in a second, the part model that we insert, which is this one here. So if you trace that down, it's a key from a computer keyboard. So you can kind of see that. It's got sort of an indent in the top. It's broadly square in its perimeter shape. So yeah, it's an injection molded key that would then be fixed onto some kind of micro switch on a computer keyboard. So it's quite a simple model. So that's the second step. You import, in this case, a copy of your part design. So again, to relate this back to the task that you've been given, the knife design, I believe that you were tasked in the marking scheme to create a molding tool for either the back of the knife or the front of the knife. Now, the back and the front of the knife are similar to each other. It's just that one of them will have a slot cut in it for the slider to slide around in. But yeah, so you'd import a copy of that design for either the back or the front of the knife. I can't quite recall which one it is. Then you'd move on to step 3. You create some material around this reference model that you've just imported. So the design that you're trying to make a mold of is known as the reference model. And then step 3 is that you tell the system how much extra material the mold will contain outside the maximum size of your part design. So in this case, that would be that green area. So that slightly transparent green block has been placed around our key reference model. And that is going to represent the kind of external size of our molding tool. So you add that in. That's step 3. Create material around the reference model. This material is then referred to as the workpiece. So the part model that we imported is known as the reference model. The material that you add around it is known as the workpiece. And you can kind of see these getting their little sort of designations in the model tree here. The reference model has the word ref after it. The workpiece model has the word or the abbreviation WRK after it for workpiece. And then we move on down to the next step. So step 4, apply a suitable shrinkage ratio to the setup. So this is related to the fact that inevitably when you use injection molding techniques, as the material solidifies in the mold, so it turns from molten material that can be injected to its final form, solid material, you get a certain amount of shrinkage. So the thought is that you will design this into the mold itself by making the mold cavity that is going to get filled with molten material a slight percentage bigger than the required final size of your part. And that shrinkage ratio will depend on the material that you intend to use for your part. All different materials will have data sheets that tell you about the shrinkage value, and you will apply this shrinkage value, but in reverse to the mold. So if you know it's going to shrink as it solidifies, you create a molding cavity that's slightly bigger than you require, so that as it shrinks back to its intended size. So that would be step 4. Step 5, find or create silhouette curves. So this is a new term as well. We haven't kind of come across this term, silhouette curves. These are basically, so if we talk specifically about the button model here, what we're aiming for is a mold which can split and allow the removal of the finished molded part. So that's split in the mold will have to be defined somehow during this process. And the silhouette curve is kind of the first step to defining this split surface. So this little blue skirt surface which gets created is generated by first tracing what's known as a silhouette curve around the widest part of our button model in this case. So that's a silhouette curve. It represents the widest part of your model, essentially. And ultimately, it allows you to create this split surface, which will ultimately split the mold into two halves, which is what we're aiming for eventually. We're aiming to make this half of the mold, which is known as the core, and then this half of the mold, which we can't quite appreciate, but it has the indentation to match this shape actually in its underside there, and that's known as the cavity. So create the silhouette curves to define where the mold will split when opening. The next step, I kind of talked about it just there when I was talking about silhouette curves. Use those silhouette curves to create a parting surface or parting surfaces, depending on how complicated your part design is. This button model is very simple, but in some of the later tutorials on this subject, we'll see that you can get quite complicated injection molded parts. So sometimes you create multiple parting surfaces and then join them together to form a whole. So use the silhouette curves to create a parting surface to cut the mold into two or more pieces. In this case, it's going to be just two pieces. Use your reference model. So this was our copy of our part that we brought in the reference model. Use your reference model to cut material from the center of the workpiece. So this is essentially hollowing out the workpiece so that it has a area missing in its center that represents where we're going to inject our material into. So use the reference model to cut material from the center of the workpiece. Step 8, use the parting surface that we created up here to split the workpiece into two distinct volumes. And then the last step is convert these temporary volumes that we've created into genuine Creo parts. So that would be the last step. And these parts can then be saved out just as standard part files, saved to the disk. They can then be used for subsequent operations. You can add features to them. They behave essentially just like any other part file, but they're always linked back to this assembly. So if you need to add any more detail to your part design, you can go away and say, add some extra features onto your button, and then open this assembly up, press refresh, and the changes that you've made to your part design get carried all the way through to these two mold halves that you've produced. So you keep that link between the original part design and the actual molding tool parts that are going to be used to mold or injection mold the part when you come to manufacture it. So now that I've run through all that, everyone should have had a chance to kind of get the virtual desktop up and running. So I think we'll jump in. So we're going to just run through this PDF kind of step by step. So I'll pull this onto another page, but you can see initially what we're going to do is create a new type of file. We're not creating parts or standard assemblies. We're creating something which is classed as a manufacturing assembly. So that's what we're going to select. And then the subtype is going to be mold cavity. Because again, that is the activity that we're doing. We're creating a molding tool, a mold cavity from an existing part. Unfortunately, I still don't have the attendance codes. If you want to send a little email through to Sarah Mountney, that might be useful, because I've asked for my login code to generate the attendance codes, and I've been told she will get back to me. But if people from this session want to send her an email and just say, Chris still needs his login code, because he can't give us the attendance codes for the sessions. That might be useful. But anyway, onwards with what we were going to do. So just ignore this part that's on the screen at the moment. That is for something that we're going to be doing later on. I'm just going to leave that open in the background, so you don't need to worry about that. So when you drop into Creo, probably the first thing, which is always wise to do, is set your working directory. By this point, you should have downloaded that zip file that I was talking about at the top of the session. So that zip file there that says exercisefiles.zip you need to download that and unzip it so that you can browse into that. And then when you come to set your working directory, so I'm going to have to go in through here. There we go, set working directory. Your option to set working directory should just be at the top of the screen there. So select working directory, and then I think I've got the files sat in one of these folders somewhere. So where are we? We're on week 8. Exercise files. There we go. So you want to point that at the folder that you've just unzipped from your zip file. Then we're going to do File, New, Manufacturing Assembly is what we're going to create. The subtype is going to be mold cavity. So that's what we're doing. And I think on the PDF that we're working from, I've just given it a name of mold example. So with an underscore between the two words. Like that. Aha, I've already done this once already today, so I'm going to put a 1 on the end of it. Then if you come into the template option, what file template do you want to use? Maybe yours will skip through this. We want to use the millimeter Newton seconds, manufacturing, assembly, mold subtype. So it's that option there. And essentially what we're interested in is the units mainly. So click on OK on that option, and it will drop you into a new manufacturing assembly setup, which is specifically for creating mold tools. So as I say, you can regard this almost the same as you would regard any other assembly. In many ways, it behaves exactly the same as any other type of assembly. So we've looked at just generic assemblies where we drop parts into them, or we use skeleton parts to control them. And this behaves very much in the same way, but it has some additional tools in here that are geared towards producing molds of existing parts. But the way that you're kind of presented with it when you first kind of drop in here is exactly the same as any other assembly. So you get your 3 base planes, and then you get a coordinate system where those 3 base planes are crossing. And again, if you're using the remote login version of this, your system may look a little bit different to mine. If you want to change the system colors, you can. You just go to File menu, Options, and then System Appearance. And if you just, it may already say default theme there, but if you just click on default theme again, it should change to look a little bit more like mine. Another thing that might be slightly different on yours is my base planes have got their names attached to them here. Again, you can set yours to do the same thing if that's easier. I find that easier if the names are actually annotated on the planes themselves. That is in model display. And where are we? Somewhere in here. I set this just before we came in. Entity display, I think. Show date and plane. Show date and plane tags. So that is the option that you need to tick. So the tags are actually the names of each one. Retrieval warning. You have insufficient access. So again, the virtual desktop version does have 1 or 2 sort of quirks to it. You can kind of cancel that error message or just say OK to it. Yeah. Just click OK. It doesn't seem to damage anything too much. The other one that you might come across when you log into the virtual desktop is that it's telling you that you don't have write access to the temp directory on C. You just have to give it an alternative location to put its temporary files. So what I normally do is I send it to my kind of own personal space on the network. So my login is CW0170. So there's just a little folder with my name on it, and I create a subfolder in there that I've called temp, and I just point it at that. But yeah, there's a few little quirks, and we'll come across a few more of those later on When we look at molding tool analysis, which is what we're going to look at in the second half of this session, again, there's some quirks with the virtual desktop that I'm going to try and iron them out with IT. But failing that, we've got a workaround as well that we can kind of put on. So anyway, that's a little bit of setup. There's lots of options in there. If you want to play around with those kind of at another time, there's lots of things that you can switch on and off. And if you want to see the effect that something's having, you can kind of just click on apply there and you'll see its effect. So if I turn the tags off and click on apply, you can see them disappear. But that's not specific to what we're doing today. Then it says, do you want to save these settings into a config file? You can if you want, and then you can call them up next time you load Creo up. But I tend to just set them per session. So anyway, the first step. So we'll have a look at the PDF. The first thing to note is one extra kind of tool or bit of functionality that we have got already on our screen is these double arrows saying pull direction. So this kind of represents the direction that the two halves of the mold will kind of pull away from each other. So in our case, our kind of final setup is going to look like this. And the thought is, if this half of the mold is regarded as being static, then when the molding operation is finished, this half of the mold will move upwards in the direction of the pull arrows. So we can set that to whatever direction we need it in. The way that we do that is there's an option up in the molding toolbar that's been activated for us. So you can see we're in the molding toolbar. It says mold. Normally we're in the model toolbar or maybe the assembly toolbar. But when you drop into these molding assemblies, it drops you straight into the mold toolbar. Click on pull direction and say I wanted the mold to split in a sideways direction rather than the top of the mold coming off vertically. I could just select this front plane there. Then when I click on OK, you can see the pull direction flips so that it's at 90 degrees to that plane, or normal to the plane, to use the kind of terminology that the CAD system uses. But I don't want that. I want it as it was. So I've just gone back into pull direction and I'm going to select that main parting plane. And then I get a little preview of where that pull direction is going to point. And if I want to spin it round through 180 degrees, I can just click on the flip the pull direction. And that would have the effect of saying to the system, it's the bottom half of the mold which is going to move. That's going to pull away from the top half. And we can regard the top half as being static. But as I say, the default option that we came in on was the one that we wanted. This is just showing you if in another example or another instance you want to change it, this is how you do it. So that will be the first step, address the pull direction. So let's work down through our PDF. So we've had a little play around with that. The first thing that we're going to do is bring our reference model in. So as I said right back at the start when we were running through the kind of numbered steps that you have to go through to create these mold tools, first thing that you do is bring in your existing design. So in this tutorial, the thought is that we, the designer, have designed a keyboard key for injection molding, and we've saved that part file onto the hard disk already. So that's what we're going to do. We're going to bring in the reference model. So you can see there's a button that says reference model. So we'll click on that. It browses to our working directory. And there's a lot of different part files in there for lots of different exercises that we probably won't get through them all, or we definitely won't get through them all this week. But I recommend that you kind of work through them kind of in your own time and bring any issues back to the later sessions. But the file that we're going to use is this one called button, which is pretty simple. So it is what it says it is. And again, if you want this little preview on, you can just click preview at the bottom of the file browser there. So button, open. There's a few setup steps here, and we're not going to go down every possible avenue. My recommended one is set this to inherited. So what this is going to do is it's going to create a copy of that button part file within this assembly. Other options include bringing the actual part file itself into the assembly. Now, that can be dangerous in some instances because what people can end up doing is making a modification in this assembly to the part file, thinking that they're not modifying the original part file, they're modifying a clone of it, when in actual fact they end up modifying the original design. The inherited one option here basically makes an identical copy of that original part file, but it keeps the original intact. It doesn't mess with it in any way. You can't affect the original. But what you can do is if you want to change the design at some point of your button or knife case, you can go back, make a change to the original part file, and then the next time you open this assembly up and press refresh, it will notice that you've made a change, and that change will then be brought through into this molding assembly. So by far the safest way of doing it, inherited. It then gives it a name indicating that it's the reference part that this is going to create. So it just adds the word ref on the end. We're not going to play around with that. So click on OK. And then we get these layout options. Now, what it's quite useful to do here is click on preview before you OK this. So we'll get a sense of what all these options are going to do. So click on preview. That is where the button part file or the reference model is going to come in. So it's centered itself around the assembly coordinate system. So that coordinate system that we looked at when we came into this assembly, which is the point at which all the planes cross each other. This part file, or the parent of this part file, the button part, also has a coordinate system in there. And all it's doing is it's aligning the part coordinate system with the assembly, the manufacturing assembly coordinate system. So that's pretty easy to understand. These other options at the bottom are if you want to create a molding tool that makes multiple copies of a part. So if we play around with these a little bit, so we'll switch it to rectangular and click on preview, and you can kind of see the effect that that's having. So you can multiply the number of copies of the manufactured part that you're going to create in this single molding tool. Now, in this example, we're only going to make a molding tool that makes a single part each time, but it's good to know that these options are available. And all I'm doing here is I'm playing with the number of copies. I can play with the actual spacing as well. So you get the idea. And I can do it in a rectangular grid. So this is very much like the kind of linear pattern that we did the other week. Or I can do it in a circular type pattern around the center point or around the central coordinate system from the assembly. So yeah, those options are there, but we don't need them at the moment. We're just going to set this to single because that's all we're going to do. We're just going to create a single mold cavity that creates a single part for every injection cycle that we're going to run. So we'll click on OK. Cavity layout is done. So we click on OK up there as well. So we brought our reference model in. So let's move on to the next step. If the pull direction is wrong, then it will need correcting. It isn't wrong. We kind of addressed that before we kind of came in here. So a workpiece is created by defining its overall shape. And in our case, we're going to create kind of a box shape, a rectangular box, and its offset distance from the reference model. So this is what we're going to do. We're going to create a volume of material around this reference model, which represents the external size of the mold itself. So this is the two halves of the mold when they're brought together to actually perform the molding process of this part. So again, there's a button that says workpiece there, so we just want to click on that. We then get dropped into this menu, which is the automatic workpiece creation menu. And what we can do is we can add material in all 3 directions or 6 directions. So we've got X, Y, and Z directions, but then we've got negative X, Y, and Z as well. And we can add them around the actual reference model. But before we do that, we need to define what we're going to regard as X, Y, and Z directions. And to do that, what the system's waiting for is a mold origin. So it's waiting for an existing coordinate system to be clicked on in order to define what we're going to regard as direction X and direction Y and direction Z. So that's what we've got to click on first. And the most obvious one to use is the overall coordinate system for the whole assembly that we're creating. And if at any point you're unsure as to why it won't progress, why are these all grayed out, again, as I've said in previous sessions, if you kind of glance down to the bottom left of the screen, the system will always kind of give you a prompt down there as to what kind of input it's actually looking for before you can kind of progress to the next step. So it's saying there, select the mold origin coordinate system. So what I could do, I could hover over it there until it kind of highlights. So mold default coordinate system, or I can click on it in the model tree over here. Either one will work. So now we've defined what we're going to regard as X, Y, and Z directions. All of these offset options then become available to us. And again, it's useful to kind of have a play with these and keep pressing preview to see how that's affecting our workpiece material. So what I'm going to do first is I'm just going to put 10 millimeters in this top box here and then press enter. I get sort of a wireframe preview. So you can see this box in blue is previewing the size of my workpiece. And if I rotate round, I can kind of appreciate that that is offset from the reference model by 10 mil in all directions. So there's a 10 millimeter offset. If I then want to change that, let's bump that up to 30 mil. You can see the effect. And then if I want a kind of full shaded preview, I can hit the preview key and I get kind of the full shaded version of it. Now, I'm just doing this as a uniform offset in all 6 directions. But if I wanted a specific offset, saying minus Z, to be a little bit bigger than the others, I could do that as well. And you can see I've now got more material on the kind of lower half of the mold there than I have in all of the directions. So you get the idea of that. You can also, given that not all parts are kind of square or rectangular in perimeter shape, you can create cylindrical workpieces as well. And you can also create kind of fully custom workpieces where you can shape the actual external shape of the mold. But certainly for our purposes, the kind of box shape or the rectangular workpiece is probably the most useful. So click on rectangular. I think we'll have uniform offsets of 30 in all directions. So if I just type that again and press enter, it will bring that 50 mil in the minus Z direction back to 30. And then I'm going to click on OK. And there's the workpiece created. So that's kind of, if you want to think of it, we've kind of claimed a volume in space as this will be the eventual outside shape and scale of our 2 halves of mold that we're going to create. We haven't created them yet. This is just kind of sketching out roughly where they're going to be. So on to the next section in our work through. So we'll just read this. The part, if relatively simple, and so the system can automatically create a silhouette curve. Right, so we're going to create this silhouette curve that you may kind of not have understood the description of what this is, but hopefully as we create it now, it will kind of become clearer. So the reason that we're doing this is we're trying to get to the point where we can define a split in our 2 halves of mold. Because at the moment we've just blocked out our workpiece, which represents the external size of both halves of the mold. But we haven't told the system where these 2 halves are going to split from each other when the mold actually opens. And the definition of this silhouette curve is the first step towards that. So we have to kind of define a silhouette first. So silhouette curve again is just a easy to find button at the top there. It will automatically try to apply a silhouette curve to the most kind of sensible point of your part. And in our case, it has actually found the point where we want to create our split surface. So you can see it highlighted in orange here. But if we just kind of dig around inside some of the inputs that have been auto kind of set by the system. So specify the surface to which the which creates the silhouette curve. So what this has done is it's selected every external surface of the button itself. So given that we only have a single reference workpiece in there, the button, the system was happy to auto select that as our surface to create the silhouette curve from. And then the second input that it's also kind of auto-populated is the direction that it's created the silhouette from. So the pink arrow there is related to the pull direction of the mold. So the mold is going to split in that direction. We've already set that. So the system essentially looks down from above onto our part, and it traces a silhouette curve at the widest point of the part. So that's kind of how it generates these silhouette curves. And that's why they're known as silhouette curves, because they represent the silhouette. If you were to shine a bright light behind this button, all you would see would be that shape. So it is the silhouette of the part itself. Now, if we then wanted to play around with this, we could say, well, I don't want my silhouette curve drawing in the direction of the pull direction. So I'll click on that box. And then let's say I click on this upper edge of the workpiece. Then it has a good go at trying to create a silhouette curve looking at the part from that direction. Now that's actually nonsense in this case, because we couldn't split it that way because it's got an indent in the top. So the two halves of mold could not split left to right as we're looking at them now, because they'd each have half of an indent in the top, and this part couldn't be removed then. So in actual fact, all the options that it defaulted to when we first came in were the ones that we wanted. So I'm going to now switch that back to as it was. So again, specify the direction for creating the silhouette curve, click on that box, and then I'll pick one of these vertical edges. And then it will go back to as it was before. And I'll click on OK. That silhouette curve's then added to the model tree. You can see it there. It's highlighted currently. Yeah, I can't select it in the graphics window there because it's kind of obscured by other geometry, but I can click on it in the model tree. So when I come to select it in a second, it will be easier to select it from the model tree rather than trying to click on it in the actual graphics window. So the next step in our kind of path towards creating a splitting surface to split the mold into two. So we're at this point. Are we parting surface? Yes. So we're going to create what's known as a parting surface, as I say, to split this mold into two pieces. And again, as long as you know the name of this next feature, which is parting surface, it's easy enough to find the button on the mold toolbar there. So parting surface, click on parting surface, and we want to create, I've already gone wrong there. So I'm going to quit out of that parting surface menu by clicking on that tiny little black X above the word controls on the right hand side. What I should have done was opened up the drop down menu, which is underneath parting surface. And then I want to click on there. Oh, that's interesting. So, yeah. Sorry, I was right in the first instance. it just threw me a little bit there. I thought we dropped straight into selecting the silhouette curve. So what we want to do is we want to extend an existing curve because we already created that silhouette curve. And what we're looking to do is extend it outwards until it reaches the outside of our workpiece. So that's kind of where we're aiming for. We want to create a surface which spans the gap between the button model, in this case, the reference model, and the edge of the workpiece. So extend curve. Again, it's pre-selected what the pull direction of the mold's going to be because we kind of set that up before we came in here. The only thing that it's asking for is a curve to extend. So click on that box there, chain, and then click on silhouette curve, and it accepts that. So we had a curve ready. We just had to tell the system that that was the curve that we wanted to use. And it's kind of auto-populated all the other kind of inputs that it needs. So it knew that we had a reference model, so it selected the reference model. It knew that we wanted to create this surface between the reference model and the outside of the workpiece. And so it was happy to kind of take the shortest route and just grow that surface out of that silhouette curve till it met the outside of the workpiece model. So we're happy with that. We can click on OK. And again, we're building up all these features and parts in some examples in our model tree. So we can kind of refer to them in the later stages of this process. So we've kind of blocked out where this mold's going to split. So we've done that step in the process. So we'll move on. We'll just check that we've not missed anything. The extended curve parting surface option can take the silhouette curve and project it outwards until it meets the outer surface of the workpiece, which is what we've just done. So the next step, which again, if you can remember back to those numbered steps that I put right at the top there, I put them there to kind of ensure that when you run through this process again, because I understand it's quite sort of detailed and in some cases quite alien, you can run through that list item by item, and you shouldn't miss any steps out. It should give you kind of a roadmap to run through this process again with a different reference model. So reference part cutout. This is the point where we take our button model and we use it as a cutting tool to cut away the center of the workpiece. So currently, this kind of green workpiece model occupies the same space as the button model. So the workpiece kind of passes through the button itself, which obviously in reality can't happen. You can't have two pieces of material occupying the same space in space. So we have to correct that. We have to tell the system, use the button model, use the reference model as a cutting tool to scoop out that central piece of material within the workpiece model. So that's what we're going to achieve next. But we need to exit the parting surface submenu that we're still in. Even though we created that parting surface, we're still down in the parting surface kind of submenu. So we don't need to add any more parting surfaces in now. So I'll just click on the green tick at the right-hand side. That's an easy one to miss. And often people try and jump back to the mold toolbar and just notice that most of the options there are now grayed out. And it's because we're kind of still making an edit to a parting surface, or so the system thinks. So you have to click on the green tick, but it is quite easy to miss because it's quite a small icon. So click on that. Then we're allowed to drop back into the mold toolbar. Reference part cutout is what we're going to do, because that's kind of the description of what we're going to do. We're going to use the reference model to cut some material away from the workpiece. And again, because this is a relatively simple manufacturing assembly, the system is happy to kind of auto-populate both the workpiece that is going to be cut and the reference model, which is going to do the cutting. So we kind of don't have to select anything here. But if we need to, you'll click on that first box and then select the workpiece if you wanted to, and then click on that second box, which is popping up and saying reference parts, and then probably select the reference part in the model tree, because currently it's kind of hidden in the middle of the reference model. But it's already done that for us. So click on OK. And at this point, it's probably investigating what we've ended up with. And the way I'm going to do that is I'm going to hide all these subsequent steps and just see what we've got in this feature here that's been named ref part cutout 1. So the way that, or the easiest way to do that, is to click on the thing that you want to isolate and then use that icon there, which hides everything else in an assembly and just shows you the thing that you've clicked on. So show only that. Now that looks quite boring now, because it's kind of hidden everything else. Well, it hasn't hidden everything else. Let me hide the workpiece manually. You can see the things that it did hide. So it hid the split surface that we created, the parting surface, because that's been grayed out. But it hasn't actually hid these two. So it hasn't hid the reference model. That is still visible, although it's hidden by our purple ref part cutout. And it hasn't hidden the original workpiece. So I'm going to manually hide these. So that icon there, which looks similar to the one that we just clicked on, but it actually hides whatever part or feature you've selected. So hide that and hide that. And then now I can be sure that all I'm looking at is this kind of feature that we've created at the bottom of our model tree. So the output of all these previous steps is this. Now, again, what I want to do is investigate what's inside this. And I can't currently do that because it's shaded in this purple color. I can't see the internals. So what I'm going to do is I'm going to use Creo's cross-sectioning tool to inspect what the internals of this box look like. And the way that we do that is in the View menu. So if you click on the View tab at the top there, or the View menu, and then go to Section and click on the drop down, and I think we'll have just a planar cross-section. And then all it's looking for is some kind of references to where I want to cut this model through. So conveniently, there's two base planes that pass through this. So there's mold right or there's mold front. So I think I'll click on mold front as my reference, and then it trims it back. So I can kind of get an appreciation of what I've created now. So it looks like I've just created a bunch of surfaces. So there's no solid material inside here. There's just some purple surfaces that represent what will be solid material eventually when we complete this process. So just rotate around, get an appreciation for that. If it's difficult to view it, it's probably worth saying if you click on shaded with edges rather than just shaded. Shaded's arguably a bit harder to kind of discern what's going on. So shaded with edges is the way I like to have it set up. So yeah, we're most of the way through this process. We kind of blocked out where the gap in the center of this mold is going to be, where the molten material is going to be injected into. We kind of defined roughly where this mold is going to split in half. We've defined the kind of maximum external size of the mold itself. It's just that currently the mold is described as a hollow box formed by these surfaces. So we have to kind of transition that into a solid block of material, or two solid blocks of material. One that represents one half of the mold and one that represents the other half of the mold. So this step that we're doing now is just to inspect how far we've got through the process and to inspect what we've created here, what this ref part cutout actually is in terms of its geometry, and is it a solid or is it a surface? At the moment, it's just a surface. So this section, well, let's keep this section view. So click on OK there, and the section view will remain. But right at this point in time, I want to switch that section view off. I've sort of kept it for future reference, so I can just quickly switch it back on if I need to. But currently, we want to go back to an unsectioned view. So if you click on Manage Views there and go to View Manager and click on the Sections tab, which is there. Currently, we've got X section 0001 selected. If you just double click where it says no cross section above, it will disappear. So you get the idea of that. If I double click on cross section 0001 again, it activates it. So the View Manager is quite a useful tool. We'll come back to the View Manager in future lessons, because when we start doing kind of animations of things and that sort of thing, the View Manager is a really powerful tool. But for the moment, we just want no cross section. Close the View Manager down, and then we're going to drop back into the Mold tab. So back into the Mold tab, and where are we going next? So we've cut our material away. We've cross-sectioned the part just to see what the internal geometry looks like of the thing that we've created so far. We've noted that that ref part cutout has an internal surface that represents the shape of that button. Now, the ref part cutout was still a single unified block of material. So I didn't quite mention that, but hopefully you can see that. There is no split line running around the perimeter of this currently. So if I hide the base planes, you can appreciate that a bit more. Now we know that we've created that skirt surface to kind of represent where we want these two halves to split away from each other. So what we're going to do now is we're going to perform that step where we split the reference model in two. So what we're going to do is ref part cutout is split in two. Where are we? Parting surface, mold volume. Aha. Bear with me here. I've lost it. Volume split. Aha, yes, there it is. So they've redesigned this molding toolbar several times over the past few releases of Creo. So you will have to bear with me when I search for the buttons that I know are there, but they've been filed away inside different submenus over the last sort of 3 releases of Creo. So yeah, but they're definitely there. So in mold volume, we're going to go have a little browse inside the drop-down menu. Under that, we're going to split an existing volume. So we want to click on volume split there. And there's 2 kind of selection boxes that we have to populate here. The mold volume to split. So we'll click on that, and we'll click on our ref part cutout model. That's what we want to split. And then the surface that we're going to use to do the splitting. So we're going to click on this second entry box here. If I can get the tooltip to pop up. So there, when the tooltip pops up, it kind of describes what it's waiting for. Parting surface for splitting the mold volume. Well, we know that it's this extended skirt surface that we created that's currently hidden, which is why it's grayed out, but we can still click on it in the model tree. If it wasn't hidden, we could click on it in the graphics window if it was visible. But currently we hid it, so I'll just click on it there. And then it highlights it with a sort of green edge to it. Then I'll click on OK. Why has that failed to regenerate? Feature failed to regenerate. Choose OK to create failed feature. Aha, this is interesting. OK. We've had a little misstep. It doesn't seem to have selected it. That's interesting. Maybe it's because I've still got it hidden. So I'm going to unhide that now. I'm going to show it. Let's see if it will allow me to do that again. Interesting. Seems to be working now. I assumed there it would let me use it if it was hidden, but it looks like it was refusing to do that. So I may back up a step there just in case anyone else dropped into the same problem. So I backed up a few steps. I made sure that surface feature, I can tell it's the surface because that icon there that is sort of a curved surface represents a surface, whereas that icon there is the curve. That sort of squiggly kind of brown line, that represents a curve of some kind. This represents a collection of surfaces that have been gathered together and knitted together. So what we want to do is make sure we've got nothing selected by clicking on some empty space. Go to mold volume, click on volume split, and the two items that it's asking for are, firstly, in this first box, a mold volume that you want to split. So it's this ref part cutout that we want to split. So if you click on that, it should accept that and say ref part cutout _1. And then you want to tell it what surface you're going to use to split that item. So you click on the second box, and if I hover over that skirt surface, it should kind of become visible, and then I can click on that. And then if it's worked, you get a kind of preview showing you, although it's not that descriptive, what's actually going to occur. So it's going to split these two along that surface and then along the external surface of the actual button shape itself. So click on OK. And then again, it's probably worth inspecting what we've created now, because this process that we're running through, every step that we do, we create kind of a new piece of geometry, if you like. And in order to adequately inspect the new piece of geometry that we've created, you kind of have to hide all the previous bits of geometry that we needed to get to that point, because they all kind of intersect with each other. They all occupy the same area in space. So what I'm going to do, I'm going to hide that ref part cutout. I'm going to hide that surface. I'm going to hide the silhouette curve. And then I'm going to hide one of these two new features that have popped up. So I'll hide that bottom one, for example. So hide that. And then what I can do is peer inside that and see what I've created. So I've now essentially got these two halves of the mold. So there's one half. And if I temporarily hide that and show the other half, there's the other half. So we're almost there. It does appear as if we are there, as if we've finally got to the point where we've created the two halves of this injection mold tool from our original part model that we came in with. But there's one final step. These two pieces of the mold that we're looking at now are, just like the ref part cutout was, they are hollow. They have no solid material inside them. They're just a collection of external surfaces that are hollow inside. And we can check that again by using our section view. So this is why I kind of put the section view in there, so that we can appreciate what each step of this process creates and what it doesn't create. So we don't currently have any solid halves to our mold. We just have these representations of what they will look like eventually. So I've gone back into the View tab. I'm going to go back into View Manager, and I'm going to reactivate my cross-section. So my XSEC 0001, double click on it, and then we get that kind of appreciation of what we've actually created. So as I said, it's just a set of external surfaces that we're now at the final stage going to use to create our two pieces of our mold as genuine, bona fide solid parts that we can save out as part files. So I don't want the cross section anymore, so I'm going to switch that back off. So view manager, no cross section. No, I don't want that. But I am going to make my other half of this mold volume visible. So I'm going to show the other half as well. So we've got this one final step to do. So if we go back to the mold menu and have a look at our PDF, we've done that step. The new volumes that we just created can be isolated, each one of them. They can be inspected. They can be cross-sectioned, selectively hid. This is the final step. So cavity insert is what we want to do. And we want to say those two volumes that we created, use them to create two finished parts that represent the two halves of the mold. So just so that I can remember where they've hidden this button these days, so it's in mold component and it's in the submenu. So here we go, mold component, cavity insert, the two volumes that we've just created that we're looking at in purple there are available. If we made a mold that had more than one split in it, which is a possibility, and in some of the other tutorials that are provided in the learning materials, you can run through those examples where sometimes you have a mold which splits mainly into two, like we're creating, but then has what's known as a slider that slides in from the side so that you can create bits of geometry that have overhangs on them. But yeah, we'll probably not cover anything that advanced in this session, but you should have a go at running through those. So all that we're expected to select here is what existing volumes do we want to use to create our solid mold tools. So we only have two in this setup. There they are. So all you do is click on them, hold down Control, click on the other one, and then we've selected both of them there. That's kind of all you need to do. Click on OK, and yet more things are created within the model tree. You can see those volumes are still there that are hollow sets of surfaces, but now they've been joined by these two genuine parts. You can tell that they're real parts because they've got a PRT extension on them. And if we open them, so just in common with any kind of assembly, if you have a part in the assembly, if you want to view the part just in the part modeling environment rather than within the assembly itself, you click on it in the model tree in the assembly, look there, and then that icon opens the part up in a part modeling environment, so in isolation. So click on open and you can inspect the two halves of mold that you've actually created. And if we want to cross-section them just to check that they are actually now solid material, we know how to do that. We just drop into the View tab, click on Section. It's looking for a reference. Now, one thing about these is when these part files are created, it's only the geometry itself. So it's only the solid material that comes into the part file. They have no base planes. They have no front plane. They have no right plane. They have no top plane. They have no base coordinate system. If we wanted to add those in now into these parts, we could, and that's probably an important step. But they don't come with them because they weren't created in the same way that we have created parts up to this point. They were kind of generated automatically by the user, us, setting up a manufacturing assembly to generate them. So there is that little caveat in terms of what you get with them. But let's cross-section this one. So cross-section, I'll use this side face as a reference for my cross-section, because if I click on that, I can then drag that arrow back into my part, and you can see the effect that that's having. It's cross-sectioning it. But this is just to check that it is actually solid material. It's not just a collection of surfaces that have been joined together with a hollow center. So yeah, I could use that. I could do analysis on that. I could get the system to tell me what volume of material is there, how much mass it would have if it was made out of a given material, all the usual things that you can do with a real part file. And in the next session, next week, we're actually going to look at how you would take this mold design and generate a CNC program to actually machine it out of a block of material. So that would be one of the kind of downstream activities that you could use these mold parts for, amongst other things, obviously. So yeah, let's cancel that section because we don't kind of want to store a section in there. Let's drop back into our assembly. So the way that you kind of switch between different files that you have open, so we're currently looking at this volume 1 part, is that you must click on that little drop down there at the side of the X, because the standard Windows way of kind of flicking between open windows doesn't work. Or does it? Maybe it does now. That's another update that they may have made to Creo. Let's see if it does work. Wow, it does. Okay. I'm telling you information from the past there of how Creo used to work, and it appears they've brought it in line with the rest of Windows, which is a good thing. So yeah, if you want to flick back to what you were working on, let's see if it still works. Yeah, it appears to work. That's okay. Right. So how are we doing for time? So we're at about 10 past the hour now. So we've got about 50 minutes left. I'm just trying to make a choice as to which other topic we explore. So at that point, what you do with your assembly is you take a save of your assembly. And then let's imagine the scenario where you wanted to modify your button design. So what you would do is you would open up the button part file. Now my system's not letting me do that because I've already got one open. But you would open up your original part file. You would make any changes to it that you wanted to make. So let me save this mold example. Do I want to save it? Yes, I do. So let's shut that down, shut that down, shut that down. I don't want to shut that down just yet. And then I'm going to erase all the files from memory that I don't need. So erase not displayed. Yes, they've all been erased. Let's see if I can now open the button file up. Yes, it will allow me to. So let's say I now wanted to make a change to this button file. Let's say I wanted a slight raised section on the top here for people that were Braille users, so they could kind of feel each key. So say I wanted to make that addition to the top. Can I quickly add that in the sort of quickest possible way? And oh dear, that's probably the quickest way of doing that. I think I might just quickly create an extrude down from this surface. So let's just put a couple of circles in there like that, and then we'll extrude them down onto the surface. This is very crude way of doing it. Something like that. Let's say I didn't mean them to go through the surface. What I'm trying to illustrate here is that all of this should now associate itself back to that assembly. So any changes that I make here should be reflected in my manufacturing assembly. Extrude to intersect with all surfaces, extrude up to next surface. That is the one that I was intending to do. So there's my button file. Let's take a save of the button. Let's now try opening up the assembly, see if we can get the changes to actually cascade through this assembly. Maybe we'll have to do a full update. Yes, okay, so that seems to have worked. So what I did there was I went back to the original part file that we brought in right at the start of this setup of this molding assembly. So if you remember right back at the start, we imported a reference model. So it was an existing design that the thought was we'd already kind of finished the design and we wanted to then create a mold tool or a set of mold tools to actually mold that design. So we brought it in, and what I said was this manufacturing assembly that we've set up here creates a copy of that original part file, and it calls it mold example1 ref.prt. But that copy is linked dynamically back to its parent part file. So when you make a change to the parent and then you open this assembly back up and press that button there, Regeneration Manager, and then regenerate at the bottom, which it won't let me do now because I've already done it once, so everything's up to date. It runs through the entire assembly looking for anything that's changed since last time it regenerated, and it updates it. So what it means is when I now open up these mold volumes, they've been automatically updated with the change that I made to the part file. And that's kind of the point of going through this long-winded kind of setup of these molding assemblies, because once you've done it, you shouldn't have to do it again for the same part file. Unless you make massive changes, wide-ranging changes to the part, which require you to maybe edit the silhouette curves, let's say, or maybe edit the parting surfaces slightly. But the majority of the setup of this assembly should be good now, should not require any further work, and it will automate that process of making changes to the original design. And this should, all those changes should cascade through all the subsequent parts. How do I reopen a session? Can you just expand on that a little bit? I'm not 100% sure. No. So, yeah, we were talking about RAM. So let me shut this part file down, and I'll shut that down as well. So you can see when I just close things, I'm just clicking on that white X at the top. So that kind of shuts down whatever I have on the screen at that point. But all those items, so that whole assembly and those part files that I had on the screen before, the system still got them held in RAM. So they're all still held in RAM. And if I intend to now load a copy of them from the hard disk, I have to flush those copies of them out of RAM first. And the way that you do that is, where are we? Manage session. Here we go. Erase not displayed. So all those items are still being held in RAM, in memory. Now, I think if I understand you rightly, so what I'm going to do is I'm going to leave them in memory. So I'm not going to erase them this time. So I'm going to click on cancel. And what I can do then is go File, Open, and then rather than bringing a file in off the hard disk, which is what I'm about to do here, what I'm going to do is I'm going to click on In Session. So you can see there's an option there that says In Session. And that will show me everything which is currently loaded in the window there, but plus everything which is still being held in RAM. I hope that kind of helps. You shut the assembly down. Yeah, as long as you didn't erase not displayed, they will still be held in RAM, and you can still bring them in by clicking on In Session. So yeah, that's a subtle difference still that Creo has with most other Windows-based programs. A lot of them do this sort of thing, but as soon as you click on Close on a part file, it flushes it out of memory automatically. It doesn't keep it in memory, but Creo does. Even when you shut a window down, Creo will keep what was open in that window hanging around in RAM, just in case you want to bring it back in again. And sometimes that's an advantage, but other times it can be confusing at best, because you think you're loading something off the hard disk and you're not. It's just bringing the copy of it straight out of RAM again. So, yeah, it's worth just kind of being aware of that, let's say. So yeah, I think we'll leave the basic setup of molding assemblies there. So I've given you the sort of outline of the process that you've got to go through to create your molding tools from your actual part files, your designs. What I want to move on to in the second part of this session is something a bit different. So what we're going to look at now, and the ability to run this on the virtual desktop does have a few kind of flaws in it. So I'll sort of confess that from the outset. Now, I am going to tackle that with IT support and see if they can correct those flaws. But for the time being, it's worth you following along as much as you can. And then when we get to the point where I've tested the virtual desktop version and I know that there's a slight error in the way that it operates, I'll tell you that what you're looking at won't necessarily tally with what I'm showing you on my screen. But the ultimate upshot of all this is that if IT are unable to get the virtual desktop version of Creo to run this next set of tools that we're going to use, in your reports, you can just describe the steps that you would go through. So you can use my tutorials as your guide and just note down the steps that you would go through for this next activity that we're going to do. So yeah, if IT do get the things working on the virtual desktop, you can do it for real using your knife design as a part file to use these tools on. But if it doesn't pan out, you can just use my tutorials as a guide to what you would do. And the topic that we're going to cover is mold analysis. So this is a set of tools within Creo. And again, these aren't included in the standard student version. They're running on site and they're running on the virtual desktop in a fashion. But yeah, you won't be able to run them at least fully on the student version. I will qualify that by saying at least fully. I think there's a cut down version in the student copy, but it's not quite as fully featured as the one that we're going to have a look at and that the remote desktop allows you to run. So what does mold analysis allow you to do? It basically allows you to take a design. So let's say that button design that we were working on, or in my case, the part that I'm going to use as an example is a part from a few weeks ago when we were playing with the ribs and drafts and shell commands. So you can see I've got that part on my screen. The actual part that you use is not that critical for this example. So if you want to load up a part, you could load up the button that we were just using if you wanted. So I would recommend take a save of that assembly that we were doing, shut that assembly down, flush everything out of memory, and just load the button in from the exercise folder. That would be kind of my recommendation. So there's my button. I've added these little nodules onto the top. It doesn't matter. You could add those, but you can run all these steps with the standard button that you just load in. So the first thing that you want to do, and as I say, I'm going to run mine with this because I've done one run of this already and I've got the results ready for us to have a look at, so that just to speed things up. In fact, it might be worth me, I'll do the button as well, but I'll have this in the background just so that we can use it for reference. So there's the button part. I want to do a molding analysis on it. And when I say molding analysis, I want some information on how successfully the injection of molten plastic will go when I inject it into a mold cavity, which is this shape. So that's what I'm looking for. I'm looking for info about, will there be any trapped air pockets within the mold? Will there be any places where the molten material ends up too hot and the material starts to degrade? Will there be any other problems when I injection mold this shape? Are there any other problems that I've not thought about that I could solve by either redesigning the part or picking a different material, let's say? So that's what you would use molding analysis to tell you. It's an analysis tool that runs a simulation of an injection molding process. on an existing part. So the way that you access it, with your part loaded into the part window there, go to Applications, click on Mold Analysis, and it drops you into this new menu, which is entitled Mold Analysis. And essentially, there are kind of very few setup steps to get these analyses kind of set up before you press run. So it's similar to what we were doing when we were using simulation and optimization and those other tools that we kind of looked at the other week. So the first thing that we have to do, how do you get that up? Yeah, if you go across to the Applications tab at the far right hand side and click on Mold Analysis. Yep, no probs. So yeah, then it will drop you back into a tab at the far left, a new tab called Mold Analysis. First thing that we're going to do is tell the system what material, what plastic we're going to use to injection mold this part. So we're going to click on Materials. And we drop into the kind of vast materials library that Creo includes. So I think it drops you initially into the ABSs. So lots of different types of ABS from specific companies. So these aren't just generics. These are actual existing types of polymer that you can buy from all these companies. And if you scroll down, you get a sense of how big this library is. So yeah, let's pick something. Let's pick a polypropylene. So we're looking for PP from this list. So PP, there we go, polyprop. And then if you browse inside there, there's all the manufacturers of different polypropes. Let's pick one at random. This doesn't matter too much, but yeah, let's just pick the one at the top. There we go. And then you can see all the different variants that that manufacturer can provide. So yeah, it's a fairly kind of comprehensive list of materials. So let's pick the one at the top there. So I've gone PP, the one at the top of that list. Then it gets us to the physical properties of that material. And some of the ones that we might want to kind of pay attention to are the ones related to the temperatures that this material kind of operates at. When you're injection molding it, there is a melt temperature minimum, average melt temperature maximum, the temperature that the mold needs to be held at to get the best results, minimum, maximum, and then a normal level. The temperature that it's recommended that you let it get to in terms of cooling before you eject it from the mold. So all the sorts of properties, the physical properties of that material that you'd be interested in if you were actually injection molding this material. But it's good enough for us at this point just to be aware that all those different material properties are in this library if we need them. But we don't need to kind of mess with any of those. We don't need to play with them. We just need to be aware that they are there if we need to refer back to them. So I'm going to click on OK. And then I'm going to move on to the next step, which is telling the material where the gates, where the material, telling the system, sorry, where the molten material is going to enter this shape. So where are the gates? Where is the molten material going to come from its hopper and the pressure side of the mold and enter this actual shape? So click on gates, and all we do is say we'd like to add a gate, and then wherever we click on this model, a gate will be added. So click on that face there, and I get a little representation using an arrowhead where that location is going to be. Now, this is all pretty arbitrary at the moment because there's nothing there for me to click on other than just the face itself. So wherever my pointer happens to be on that face is where that injection point or gate ends up being placed. A better and more sort of repeatable method of doing that is to design in some points into the actual part itself. So what you might do in this case is you might momentarily quit out of molding analysis and think to yourself, right, I want to put a gate and I want it dead center in this face. I want it in the center vertically of the face, and I also want it in the center horizontally, for example. So what I'd do is I'd create a sketch on the face first, and I'd probably create a vertical line and a horizontal line, and then I'd use constraints to lock that horizontal to the center point of that vertical edge, and to lock the vertical line to the center point of there. So where the two lines met each other, I could be sure that I was in the center of that face there. And then what I could then do when I'm adding a gate is I could select that point, and then I would know that I had precision control over where that gate was located. So there's a little bit of setup work that if you want to do this kind of repeatably and with precision rather than just arbitrarily clicking somewhere on a surface, that would be the way that you'd do it. But when you'd done all that setup, you'd use this same technique. It's just that you would be able to then know that your arrow was in a specific location rather than just wherever my pointer happens to fall. So that's a little bit of setup there, but we're not going to do that in this example. This is just an example of how you would run through these setup steps for molding analysis. The other thing that I can control is the diameter of the gate itself. So because we've loaded this button part file in, we've actually imported its unit system as well, which is in inches. So our units are showing in inches. But if we wanted to change that diameter, we could. So let's change it to 0.2 and click on OK. And you can see that the scale of the arrow itself is actually showing you the diameter of the gate itself. So the gate is actually that diameter. The arrow scales itself either up or down, depending on the actual diameter. Then if I wanted to edit that gate, I could go back in and edit, and maybe I could change its diameter again and update there. Or can I edit its position? Will it let me? No, it won't. I'd have to delete it. If I wanted to put it in a different position, I'd add another gate in. Now I'm going to leave a single input into our mold for speed reasons as much as anything. The more gates you add in to a particular setup, the longer the calculation time will take when we actually calculate this molding analysis. So just know that I could add as many gates in as I wanted. So I'm just adding them in now on whatever surfaces I wanted to add them in on. So you can see I've added one up there, one there, one there. But for this example, because I know that these analyses take a long time to calculate, I've left it to just a single gate on the setup. So I'll close that down. Then I'm going to go to this third icon. This is kind of the final step before we come to run this analysis. So what have we got here? It's telling me that I've already set the material up. So it's saying, here's the material that you selected. If I want to change that there, I can drop back into the material selection and change it. And these values here, it has already populated them with the data that came out of the material itself. So when we were looking at things like mold temperature in there, it's already pulled those values out of the data sheet for that material and entered them in here. So certainly when you do your first pass analysis, I would leave all those as their default values. And then depending on what the results tell you, it may recommend something such as, why don't you reduce the filling time? And then you can come back here and make an adjustment. But certainly with the first kind of analysis that you do, it's good to just run it with the default straight out of the data sheet. So other things that we can set up here. So we're going to run certain simulations, and these are the sort of things that we're going to look at. Data related to any air trapped in the mold, so air traps. Melt front time, if you hover over these, you get a brief description of what they mean. So show the melt front pattern with respect to time. So that's basically as the material enters into the mold, if you think of it as molten lava, the melt front is the front edge of that injected material. So it's measuring how long that front edge is taking to fill the entire mold. A general moldability is the shape that you've given it to analyze, and the gate location and the material going to lead to a part which is generally easily moldable, moderately easily, or very hard to mold successfully. So things like weld lines, it's going to tell us about, which we'll talk about in a minute. Sink marks, so that would be any little dimples that are going to appear where we don't want them. Yeah, you get the idea. It's going to run through all these different sort of properties of what we might want to have information on if we were going to create this part using injection molding. There's a couple of additional ones that we can switch on. So calculate the maximum cooling time based on the filling result is one option that we can switch on. Calculate sink marks is another option. I sort of pointed at sink marks up there. Again, I'm going to leave them switched off for this example. There's specific questions in the marking scheme for your project that certainly talks about sink marks. So when you come to that point, I would switch that option on. But it does incur some extra calculation time. So that's the reason I'm leaving it switched off now. But just know that those two are options. You can switch them on and run an analysis with them switched on. The last option before we actually get this thing running is the mesh element size. So one of the sort of calculation stages that the system's going to have to run through when we eventually press run is that it's going to chop this solid material that we've given it, so this button, up into a finite number of elements, in the same way that when you're looking at stress analysis and deformation, you talk about finite element analysis, and it essentially subdivides the solid material down into kind of regular shaped elements. A similar thing happens here. And we only have a very sort of broad control over it. Do we want a coarse element size where the calculations will run relatively quickly? Do we want to step it up to a medium element size? Or do we want it maximum accuracy, but the analysis is going to take significantly longer to run? And again, for this example, we'll leave it set on coarse. My initial way that I would run these is all the settings down to the bottom, sort of level first, run an initial pass, see what issues you're highlighting, and then maybe step up the sort of quality of the analysis later on. So what's the last step? Click add. So that's going to add an analysis setup with all these options as they're set currently. And then it's going to give us a warning saying, if you want to change the gate positions at any point, update the gate layout from the gates setup dialog box, and then add the analysis. So we'll click on OK. We get an analysis number 1, and then to run it, you just tick the little box at the side of it and click on run. The reason that it's set like that is I can run multiple analyses end to end. So if I want to run one where the filling time is 1.35 and then run one where the filling time is 1 second, I can do that. So if I click on add again, I should get a second analysis. And if I click on them both, click on run, it will run the first one, and then it will continue running and run the second one. So maybe if you're leaving a machine overnight and you've got lots of hours to kind of use to calculate these results, set up multiple analyses and run them all end to end. And then you can drop in and view the results from multiple ones. But we'll just run analysis number 1. So then you will click on run analysis. Now I'm not going to do that because that will take, I think, a minimum of about 12 to 15 minutes, and we kind of don't have the time. If you want to run yours at your end, that's okay. But what I'm going to do at this point is close out of there and drop back into my other example that I've already run the analysis on. So this one I ran earlier using this as an example. With similar setup criteria to what we were just looking at, that button. It is a similar shape to the button. It just has these additional kind of ribs on the inside. You can see the gate location as well. So it was a single gate setup. And then what you're confronted with when that analysis eventually finishes is all of these icons, or the ones that you allowed it to calculate, become ungrayed so that you can click on them. So if I click on moldability, that's looking good at a first glance. That's sort of a general advisement. There's not a great deal of detail there, but it will allow you to kind of quickly identify areas where you're going to have to investigate further. So I was hoping that these ribs might cause some sort of issues, and I might be seeing something that was coloured in the yellow or the red area, but I'm not. So it's quite a boring kind of result, that. Melt front time, we get a nice rainbow plot. So is this what I would expect? So it does appear to be. So I know that the injection point is over here. So I could surmise that the material that had to travel to the opposite side of the mold from there was the material that took longest to fill the mold, essentially, which is what we're looking at. The material that's furthest away from the injection point, it takes the longest number of seconds to get to its eventual location, which is kind of what I'd expect. So we can go through all of these and we can analyze them. But the quick way to use this and to get an idea of whether there are any issues to your setup that you need to address is to click on Results Advisor. So we'll click on there and see if it's identified anything that we would class as an issue with the setup. And it has, it's found two. So if I double click on Air Trap, I get this kind of graphic where these little kind of turquoise spheres represent areas in this mold where pockets of air might end up trapped. And obviously that would be a problem. So what does it tell us about that? Air traps found inside the cavity. This may cause voids. Voids are never a good thing, either visually, because let's say this was some kind of box, some kind of storage box. There is the potential that instead of being a continuous flat face, that would have a little kind of ripple in it there, or a little piece missing, a void. Or that void could be buried slightly under the surface. And if this was a structural part, that void would weaken the overall structure, obviously. So air traps, never a good thing. But it offers us suggested solutions. You could try increasing the filling time. So we saw the filling time as one of the setup options. You could play with different gate locations. You could reduce the injection speed, which has kind of the same effect as increasing the filling time. You could modify the size and location of the vents. So we kind of haven't put any vents in this setup. And by vents, I kind of assume that it means what I could do is go back into my part design and add a kind of sacrificial piece of material that pops up out of this rib there. And then during manufacture or subsequently to injection molding, when this part gets ejected, a cutting tool could come in and chop that sacrificial piece of material away. So it's almost like a runner or a sprue that sticks out there, knowing that the air is going to congregate there. And that little sacrificial piece of material may have voids in it, but it's intended to be discarded or recycled, more likely. So yeah, that would be one solution. And then maybe I would run it again with this, let's say it's sort of a thin cylindrical piece of material that sticks directly up out of that face at that point. And then this analysis will probably identify that there would be an air trap within that piece of material, but we could be comfortable in the knowledge that that piece of material is going to be removed through some sort of cutting action after this part is created. So that would be one solution to that. Other solutions we've kind of been given there. So is there anywhere else? Yeah, we could do the same thing over here. So we could address it in that way. We could make a change to the actual design itself, and put kind of sacrificial bits of material into the design and sacrifice the speed of manufacture, knowing that we were going to have to put a chopping manufacturing step after the molding manufacturing step. But inevitably, you end up having to do that to a certain degree anyway, even if it's just to chop away the excess material where the injection gate is. So, yeah, that would be one way to solve that. Degradation, what is it telling us? The resultant melt temperature is more than the maximum working temperature of the material. So that seems like a bit of a problem. Change the gate location is one possible solution. Increase the filling time, reduce the injection speed. So those would be a few suggestions that we would run other analysis runs and play around with those sorts of options to try and get some sort of better outcome. And this is kind of the way that you would use these tools. You would run subsequent analyses, changing things, using this advice in the results advisor, and sort of gradually, hopefully, improving the outcome of these simulations each time. And certainly in your project work, that's what you're expected to do. Run several iterations and get a sort of quantifiable improvement in the molding results that the mold analysis tool is telling you that you're going to get. So yeah, there's lots of different items to address here, and these are all kind of well sort of established molding terms in terms of injection molding. If you're wondering what frozen layer ratio is, you can research that. This is purely to kind of give you a little kind of tutorial on how you specifically use this tool within Creo. The actual terms that are being used here, this tutorial is not intended to give you all the molding knowledge that you need. It's purely how do you use the software and a little bit of an insight into the sorts of advice that the software will give you itself. But certainly there's an expectation that you would then go away and research what a lot of these terms mean, because they're not specific to this piece of software. They're general injection molding terms, like velocity vectors, volume shrinkage, and all these things, and weld lines and sink marks. So yeah, so how are we doing for time? We've got about 15 minutes. So one of the things that I will say is that when I ran the virtual desktop version of this earlier, the thing that wasn't working and was a sort of major issue was the annotated scale on these rainbow plots. So all these kind of plots that you can generate, and you can have them mapped onto the parts here. You get this scale, which is useful. And as you can see on my screen, the scale is annotated, so you know what the scale represents. And on the virtual desktop version, all this text was missing. So there's something a bit strange happening with the virtual desktop install of Creo. Now, someone say my analysis doesn't have the numbers either. Yeah. So I think it's a system-wide thing with the virtual desktop installation. I don't think it was specific to mine, because Sam is saying he's experiencing exactly the same thing. So yeah, if we can't get that fixed, then in terms of your project work, you kind of have two options. Option one is that there is a version of this molding analysis available in the student local copy of Creo that some of you have installed. It's just that some of the features are missing. So you can do a sort of reasonable approximation of this, but some of the more sort of fancy options, I think that the main ones are that the material library isn't as fully featured. So the quantity of materials that you have access to is significantly cut down. I also think that you are not allowed to add more than a single gate into any analysis. And there may be some cut down options in terms of sync marks as well. But that's probably warrants further investigation just to check that. So that would be option one. If we don't get the remote desktop version of this working 100% before you have to complete your project work, then you can use the student version and you can do as much as you can with that student version. And I appreciate that there are cut down options within there. So you won't be able to get your analyses up to that sort of higher level of detail, but that's okay. Option two is the way that the project kind of brief is worded when it comes to molding analysis, certainly, is we've inserted the word describe. So it says something to the effect of describe the steps that you would go through to perform molding analysis on your part. So what you can do is you can watch back the videos that I've provided. So there's a lot of this content which is in these general Creo videos. So if we scroll down a bit, you can see, where are we? Mold analysis 1. There it is, and mold analysis 2. So there's a lot of the setup steps that are run through in here. So I'll just turn my voice off on those. So there's a lot of setup steps and a lot of data in there. And if you watch that through, it's perfectly acceptable in the project to just describe the steps that you would have to go through to analyze your knife design. And that's why we've worded it like that. So that given that we're working off site, and we may not have access to the full mold analysis tools, it's acceptable just to digest the videos and kind of describe the steps that you would take to analyze your knife. So yeah, you can go either way with that. I don't really mind too much. And then obviously the third option, which is the most preferable, is that the IT support people manage to get the virtual desktop version of Creo fully functioning in time, and then you can actually perform the analysis for real on your actual design. So yeah, we kind of broadly got three options. We got two at the moment, with a possible third coming online. If I can sort of communicate back to the IT support people that there's an issue and they can get that fixed, then that is the most preferable kind of option for that. So how are we doing for time now? I think we'll probably leave it there. I don't want to drop in and start something new at this point, given that we've only got 5 minutes remaining. What I would say, though, is that if you have a look at some of the content in these videos that I've linked to, so where are we? Molding analysis, or maybe some of the written content for this week. Yes, here we go. So there is a Creo Basic Mold Creation zip there. Or is it this one? I'm just having a look. There's lots of content here, essentially. It's this one. Yeah, I knew it was there somewhere. So this Pro Mold exercises, all the files that are needed to support that, you have already downloaded. So they're included in that exercise files zip. That's why there was a lot of files in that folder, because they also support all these other activities. So these are quite small, sort of self-contained little activities where you can load files in from that folder that you've unzipped. So there's a file in there called draft split curve. And this is practicing using the draft commands that we had a look at a few weeks ago. So adding draft angle to the faces of a part that's intended to be molded. Creating silhouette curves, I think, is in here. So there's a little bit of practice on that as well. So a lot of the skills that we've already covered, a lot of these activities allow you to sort of practice the skills that you're going to need. So creating split surfaces, Using some of the analysis tools in the system to allow you to analyze the amount of draft that a design already has on it. So we said draft angles are to help a molded component be removed from the mold more easily. And there are analysis tools within Creo that allow you to look at an existing design and analyze whether it has adequate draft angles on it already. So that would be this section here. And it kind of colors the surfaces depending on how much or how little draft they actually have. And then obviously the intent there is if there isn't enough draft angle, you would then edit your design and you would increase it. What else have we got in here? So this last sort of portion here is very much in the vein of what we did at the start of this session. So it's creating a manufacturing assembly. So you could kind of be reasonably confident that you could skip through most of that section. And you can see they use a lot of these similar sort of files. So yeah, I would recommend that you have a look through that material, run through some of that in your own time as well, as is always good for these sessions. There's more material in the learning materials than we have time to get through in the sessions. So the expectation is that you'll run through some of that in your own time. But I think we'll leave it there. And then, as I say, looking forward to next week, what we're going to kind of tackle is something like this, which again, all these videos are already there. If you want to be sort of getting ahead or reviewing anything that we've done, I've kind of uploaded all these sessions already. So I'll silence me again. Shut that one down. So we're going to look at setting up a CNC machining sequence. And in this example, the part that we're going to be machining is a design for a half of a mold. So you can kind of see that sat there. And a lot of the setup steps are similar to what we've done when we created the two mold halves. So you can see there's something that looks initially like our workpiece. So that green piece of block of material there looks very similar to our workpiece in our molding setup that we just created. So yeah, some of that will be familiar, but this is intended to create CNC programs that will eventually machine your mold cavity from a block of material or from a piece of stock material. So yeah, I think we'll sign off there. As I say, that's what we're intending to do next week. Have a little play around with some of the extra molding activities. I will go away and raise it with IT that we've got issues with the molding analysis tool as well. I'll do that now in the last sort of 5 minutes of this session. And hopefully we'll get some sort of solution to that. Yeah, unless anyone's got anything. My version of remote desktop does show values. Oh, so there's a possibility that is a sort of isolated problem. So yeah, I will investigate that further. I think what I'll do is I'll log in to remote desktop from a few different computers and see if I can get a version of Creo that has the values displayed. And then I'll feed that back. Is there an option that needs to be ticked? I don't think there is, but it's probably worth further investigation. So leave it with me, is all I'm saying. I will raise it as a possible question with IT, and if they can solve it at their end, that is the best way of going about it. But I will run a few experiments as well. I will log in from a few different systems and see if I can get it to work. So yeah, I'll see everyone next week, and yeah, run through some of those extra activities from this week as well. Okay, bye.